Okay, let's talk about chapter 7.1 rational index. First of all, we will talk about the roots of a number. So look at here. Uh, in general, if x squared is equal to a, then x is the square root of a. And similarly, if x cubed is equal to a, then x is a cube root of a. If x to the power 4 is a, then x is the fourth root of a. So in general, we can conclude like this one. If x to power n is a, then x is an nth root of a. So let's look at further. We can also divide these two cases, whether a is a positive integer or not. A is a real number or not. And also we should say that n is a positive integer first. Let's consider. Now, for number of nth root of a, if a is a positive number which is larger than 0, then a will have only one positive root. Say here n is odd, a is larger than 0, then we have one positive root only. If a has if a is larger 0, but this time n is even, then we will have one positive root and one negative root. One positive root, one negative root. So let's say x squared is equal to 64, then the total roots of x are positive and minus 8. Now, if a is smaller than 0, which is a negative number, then once again we will have only one negative root. If nth root of a is negative and n is even, then the root does not exist in real number system. Okay, once again, it does not exist in real number system. It doesn't say that it does not exist any root, but it just say that it does not exist any real roots. So actually, if you remember that in last term we talked about quadratic functions, that we have already introduced an idea that there may be a complex root. So the imaginary number I, you remember, they are actually complex number roots. But here, we would like to emphasize that in real number system, there will be no root if this combination happens. So a is negative and n is even, there won't be any real roots. Okay, so remember this one. And actually, there can be more than one root for this case. There could be more than one root, but we consider real numbers only. So if you are given a imaginary number or complex number, if you take the root of this, that actually will give you 3 roots. Okay, since you are a cube root, so you must have 3 roots. You must have 3 roots. But here we just consider real number only. Remember, real number only. So for this complex number, you can just put it aside first and see if we have a chance to take a look of it later. Now let's talk about rational index. In the past, you have learned index, but the subject is limited to integers only. So say you are talking about a to power 2 or a to power 3, etc. So these are integer index only. These are integer index. Now we extend our index to consider rational index as well. So what are rational? You can think of fashion. So fashion, like here. This one, 1 over n is a rational number. Okay, so the definition of rational index are like this: a to power 1 over n is actually n root of a. It's actually n root of a. And similarly, if we add a denominator, then we will have this type. You can consider this one to be like this, and thus we will achieve this result by the inside the bracket we will have this one, and then outside the bracket is to power n. We may also interpret this this way, like this one, and thus we will have am inside the bracket, outside the bracket is the nth root, and that's it for this rational index. Now let's look at this example warm-up one. So without using calculator, find the value of these examples. First of all, 36 to power 1 half, then you can turn this into, which is actually root 36, and then you will have 6. And for b, this one, so we will have so we can turn this inside first. Consider this one first, okay, which is cube root of 125, and then outside you bracket square, which is actually 5. The inside is 5 and outside is to power 2, then it is 25. For C, you look at here, then you once again we have to consider several parts. We have to deal with the negative. If you remember that we can actually turn the upside down, but here I will give you this direction first. Let's consider the inside. So I split it in this way. First you obtain 1/3. Now since you remember this one, a to minus n, I write in this another way. I write in here, then we will have this one. So accordingly, so for inside we will have 1 over 81, and 1 over 81 will be 81. So the answer is 81. Alright. Next, example 2. Now you use a calculator. You are allowed to use calculator. Then you can just put it in the calculator. But I would like to show you the step in using calculator in case you don't know how to do with it. So the solution, so this one, 27, you can look at here, is you have to input, this is the power key to power key, and then you use brackets. Next is 7 over 3, so you just input this fashion, it's easy. And then you don't forget to close the bracket. Although some calculator, if you don't excuse me, if you forget to close the bracket, it's alright. But imagine if you are dealing with complex equations, I mean they require a lot of steps, then it is better for you not to forget to add the bracket, and then you can have the answer. So I just show you off. So, and for this one, this 5 shift, this one is actually turning the power to 1 over 5, 1 over 5, turning this into 1 over 5. Alright, so remember this. This is actually wood. This turned to a wood. Okay, so you shift the power key, we will actually a reverse function, and that's what let's just demonstrate more than one way to input your calculator. And you go through the example by yourself. Now let's come to the laws of rational index. Basically, it's just the same as indigo index. Just the same as indigo index. Okay. However, when we encounter this rational number, we will say again, instead of m and n, we turn it into p and q, and we suppose them they are any rational numbers. Okay, so in case you are not sure what is rational number, you can just imagine it. Any number can be expressed in a rational way. Okay, so say 2 over 7 is obviously a rational number, and you should have learned how to turn this decimal into a rational number as well. Moreover, if I give you an integer, you can also turn it into 4 over 1, which is another rational numbers. So just remind you the relationship between integer and rational numbers. And this, you can see that the laws of integers the laws of indigo index actually apply to the rational index as well. Just the same. Okay, so you can look at these examples as well to get yourself familiarized with these cases. Now let's do some exercise and look at example 3 here. So you have to simplify this and express the answer with positive index. Now let's see, you have to express the answer with positive index. So I'm going to show you. So the first step, we copy the question first. Next one, it will be I would say you take out the bracket, then you put the same base number together, then you will have x. This minus 1 over 3 plus minus 1 over 3 will be minus 2 over 3. And then this is 1. 1 minus 1 over 3 will be 2 over 3. And is this the final answer? No, since you still have the negative index, so you have to turn this into a negative one in a fashion. I mean, so this is the final answer. This is the final answer. Okay? Okay, let's do some more. Example 4. So you are told to simplify this one. So remember, they are not the same. 1 3 is inside the wood, 1 is outside, which is a crippled wood. Now we turn this symbol into a rational number. So which is this symbol is actually this one. So whenever you see the root, if there is no number, actually it's a square root, and it's a fraction. And this one, so 3 is the denominator. Alright. Okay. Then next one, both of their base are A, then you can actually do the subtraction. So for the subtraction, I suppose if you are not familiar with, you can use calculator. Otherwise, I'm not stuck on it too long. It's A to the power minus 1 over 6. And you turn this into a positive number, and that is the answer. Okay, next one. Example 5. Now you are asked to simplify this one. Once again, I copy the equation, the question, and then you have to turn them one by one carefully. So this one, I can actually have, and then 4 is maybe I slow down first. Okay, the square root is actually to power 1/2, and then once again I move it slowly. So the 1/2 is for everyone. Now we can do the combination. So we have 4 to 1/2 is equal to 2, and this one y, so you may say this is actually minus 3 over 2 plus 3 over 2. So clearly you will have, this is 2, this is y to 0. So the final answer is 2 times x to power 0, to x to power 2. And this is the final answer. Next one, another type that question. There is no A unknown on the base. Instead, they change to numbers. However, no worry. You should be able to notice the clue that they are related. So what does it mean? So actually, you can turn 3 to keep it as 3, but 9 you can turn this into 3 to power 2. For 2, you just keep it, and then 4 you turn it into 2 to power 2. Okay, and then basically, whenever you see the numbers, try to think about or turn their base into some simple prime number, 2, 3, 5, 7, and etc. Next, we can do the you can choose. Okay, you can choose to do to keep the brackets or not for the index. I will try to remove the brackets here first, and then next one I will be n minus 1 plus 4 minus 2n. So this is addition. This is an addition. Now you can combine them. So you will have 3 is 3 minus n. 2 is this 3 minus n as well. Nice. Okay, and then you can say this answer. Okay, if you want to push further, some of the people will actually try to show like this. So he can turn 2 to become a denominator like this one. So you can see this is, if this is negative, then this is positive. So you can turn like this, but it's not that necessary. However, you should be able to discover this relationship. And that is the end of chapter 7.1.